When we think about artificial intelligence, we usually imagine GPUs training deep neural networks, or CPUs running logic and application code. But behind the scenes, there's another player, DPUs, that keeps everything moving smoothly. A DPU is a specialized processor designed to handle the movement of data, not the processing of it like a CPU or GPU. It's built specifically for networking, storage, and security tasks in data centers and cloud environments. In large-scale AI applications, like training massive language models or running inference across thousands of nodes, data has to move constantly between memory, storage devices, other servers, and even different layers of the network. This is where the DPU steps in. It offloads these tasks from the CPU and GPU so they can focus entirely on computation. Okay, so here's what DPUs actually bring to the table. First, there's network acceleration, which means, fast data transfer across clusters. Then we have storage management, basically handling all those input and output operations. Next up, security enforcement. DPUs run encryption, firewall, and monitoring tasks, keeping things safe. And of course, CPU and GPU relief, which is all about reducing those annoying system bottlenecks. With DPUs doing the heavy lifting in data movement, the entire AI pipeline becomes faster and, honestly, way more scalable. A typical DPU packs quite a punch. It usually includes multi-core ARM CPUs, network interface controllers, often called NICs, high-speed memory access, and dedicated engines for encryption and compression. You can kind of think of it as a smart, programmable network controller that's built for today's modern workloads. So, where do we actually see DPUs in action? Well, they're now pretty much standard in hyperscale data centers. You'll also find them with cloud service providers like AWS, Azure, and Google Cloud. And of course, in AI clusters used by research labs and enterprises. DPUs enable better resource isolation, faster AI training, and not to forget, more secure multi-tenant environments. Alright, let's break it down. We have three main components here. First up, the CPU, which is our general-purpose compute engine. It's responsible for handling tasks like application logic and operating system tasks. Then we have the GPU, which is primarily a parallel compute engine. It's used for tasks like AI training and graphics rendering. And finally, the DPU, which focuses on data movement and control. It's key for networking, storage, and virtualization tasks. Now, as AI models continue to grow in size and complexity, the importance of DPUs is set to increase significantly. They're really at the heart of the shift toward disaggregated infrastructure, where compute, memory, and storage are separated and optimized on their own. In essence, DPUs are what make scalable, secure, and high-performance AI systems possible. So here's the thing. While DPUs may not be running AI models directly, they're crucial in powering the infrastructure that allows those models to thrive. They're like the hidden engine that's driving the AI revolution forward. Thanks for watching. And if you're building, learning, or researching AI systems, don't overlook the role of the DPU. It might just be the most important chip you never thought about.